Alright, this is going to be everything you need to get started on the heap project. I'll start off first with a rough roadmap of how I personally would approach this project. So the first step would be to watch this video and follow along so that I know where all my resources are. I'd go to the sites and files that'll be visited in this video so that I have them open once the video ends. I would then review those resources in the order that they're introduced, and that'll help me fill in any knowledge that I need. And then I'll be ready to look at array heap min-pq, which is the file that you'll be using to implement your heap. In here, I'd suggest planning your methods, especially with your group, with the percolating operations as well, because the logic there can get pretty tricky. Be clear about return values, parameters, and expected behavior for all of your methods. And then while you're planning your methods, you might see an operation being performed multiple times. I would consider making that a helper method. Even if it is a very short helper method, it'll still reduce the chance of error and improve readability for both your group members and also maybe some TAs. This project does have stricter runtime requirements, so I would analyze my runtimes at a high level after that planning process. And really ask myself, will my methods have sufficient runtimes for the tests and the requirements? Definitely do this before writing any code, since rewriting comments is, of course, a lot easier than rewriting code. And then after you have all of your logic figured out, I'd say that you're ready to start coding with your group. Let's actually start going back here to look at the spec. Similarly to maps, you'll want to read the documentation for the interface that you're implementing. This is going to be extrinsic min-pq. This file is going to be in the same folder as your array heap min-pq. And we'll talk more about this later. For now, let's scroll down. We have here a naive implementation. It's available for you if you choose to read it. For now, let's talk about how we can translate what we learned in lecture into this project. So we talked about using an array to implement a heap, but we actually don't want to worry too much about resizing, so in this project we'll be using an array list. We're given here that we'll have a field named items, and it should be an array list of priority nodes. So you can imagine that the priority node is the object that's going to be containing our items and its corresponding priority. If it's been a while since you've used array lists, I have a group of methods listed here that you might find helpful. You might not use them all, but they're there for your convenience. So let's go back to the spec. We're also given this field here, start index, so we get to choose at what index our array list will contain the first node. The default's going to be 1, but you can change it if you want. We also talked about needing immediate access to any node's parent and its children, and we talked about the calculations to get those indices. I also have on this slide here those indices, the calculations to get those. This is if you're starting at index 1. You can imagine if you're starting at index 0 or 2, you'll want to modify some constants in these equations. So looking back here, I'm going to jump to the bottom a little bit. The invariant checker. You know that items will need to contain our heap, and the parent of any node must be less than or equal to both of its children. And we know that this is just going to be the invariant for a heap. And then this is a reminder that we're going to be implementing a min heap. If you accidentally implement a max heap, this is the error that you're going to be seeing. So at this point, it might be helpful to actually look into IntelliJ and look at those files that are available to us. So the first thing that we're going to do is go into the heaps project. Let's look at source, priority queues, and let's take a look at array heap min-pq. So this is actually the file that we'll be editing. You can see that we have our starting index, which we can modify if we want. and also the items, which we should be initializing as an array list of priority node. Let's take a look at extrinsic min PQ. Again, this is the interface that we're going to be implementing. This has all of the documentation for those methods, and we'll talk more about that later as well. For now, let's move into priority node. This is the node that we'll be working with in our array list. It's important to note that you can get the item, you can get the priority, and you can also set the priority using these methods available here. So now let's go back to the spec. Now let's look at the runtime requirements here. You can see that we have some stricter requirements. This is why I recommended earlier that you'll want to keep track of your runtimes as you plan your methods out. If you're using an operation in your array list and maybe you're not sure what the runtime is, you can actually take a look at Java's documentation for the array list class. So I have a link here. You can also just go into your browser and search array list documentation, and it should be the first thing that pops up. And this documentation is really clear in that it gives you some nice runtimes, such as, that if you're calling get, that will probably run in constant time. And again, let's go back to the specification. So you might find when you're first doing this planning of all of your methods that only using an array list might be too slow for some operations. So if we look further down into the tips section of this spec, we have a hint here. We have a tip that's hinting towards using a separate data structure. This means that it's worth considering a trade-off between space complexity and time complexity with this particular implementation. So you are allowed to import ADTs in data structures that we've learned so far, as long as it is not another implementation of a priority queue. So if you're unsure about the runtimes for any objects methods that you import, you can, just like I did with the array list, you can go to the official documentation for the object, and you can find the runtimes there. You should, of course, use your runtime analysis skills to identify if that data structure will help. Let's go down into the grading details. So we are using stress tests, which means that there's going to be some instances where if one test fails, the others will fail as well. So if you see a red big block of code where all of the tests you failed are coming up on Gradescope, it could just be that your code threw an exception or that your code takes an excessively long time. That's all for me. Next up, we will talk more about the method requirements.
Hey guys, your amazing TA Jackson here. I'll be talking about extrinsic min PQ interface and also some naive implementation. And finally, we're going to talk about the most important stuff, implementation of the array heap min PQ. So first, let's go over the interface. One thing I want to point out is that you're not going to write any code in this file. What it does, it just provides you kind of a sort of a template for you to follow. So as you can see right here as an example, so in the extrinsic min pq.java, we just declared these methods here: add contains peak, remove min, and change priority. You don't have to write a single line of code in this file. Matter of fact, do not touch it at all. What you need to do, the only file you need to kind of modify or add your code into is going to be this array heap. As we provided naive min pq.java, this is just for you to see an example how we would implement using an array list. But this one's pretty slow as it's not going to be meet to our runtime requirement. With that being said, let's talk about runtime requirement first of all. So we do have runtime requirement on pretty much all methods mentioned above. It's going to be within this big O of log n. That means that's the upper bound. So which means we need to either have a constant runtime or we got to have a log of n runtime. Pretty much for all the methods you have here. Of course, you can do any helper methods. We don't have any runtime requirement on that, as long as you meet this requirement for the public methods right here, as you can see. right over here. So yeah, that's pretty much it for that. As I mentioned, you can take a look at naive implementation as well. And yeah, before we actually talk about the implementation of each method, I would like to take you guys to back lecture 14 here. So if I were you, I would definitely review this lecture before writing any code on or inside of this file here. So, of course, you can watch the recordings, but at least go over the slides if you can. One thing I want to point out is on the slide 10 here, this lecture talks all about heaps array implementation, right? So on here, it says we implement the heaps with an array. We're not using an array to representing our min heap in our project. We're using a list. So as you can see, highlighted area here and also here. So we actually declared this for you, so you don't have to worry about that. But just know we're using an array list instead of array here, but they're pretty similar. So this one is a zero-based array. As you can see, it starts at the 0th index. And then how do I know this is a min heap? This is because I have a letter A here. Letter A, of course, the smallest letter in the alphabet. So if it's on the top, that means it's a min heap. Uh, on to the right, it has some functions useful for you. For example, peak min, right? And then we have left child, right child, and also how do you get the parent. Of course, you can use a index one based array to implement this. The math is going to be a little easier, simpler, but either way, you can do it. So in this case, I'm just going to be talking about zero-based array here. All right, so with that being said, let's turn our attention back to this array heap min tq dot Java. So here, as you can see, we declared static final int start index. We'll talk about that later. And of course, we have a list here. And then you can add any fields that you feel like is going to be necessary for this program. And just don't forget to declare it or like initialize it. And we have this private swap function for you. This may be useful. I personally highly recommend you to implement this. What it does is just a helper method for swapping the items after like at two different indices of the array heap that we got to implement. So let's talk about the add method right here. So as you can see, we're given two parameters. The first one is going to be item. The second one is going to be priority. What it does, it just adds or inserts an item with a given priority value into the min heap that we have, which is going to be implemented by an array list, of course. So from now on, I'll call it array heap. So inserting that item into our array heap with that priority queue, this one is a double, which means we could have something like 1.1, 1.2, right, instead of all integers. So we could have double values, and then we're sorting it based on the priorities, not the items, but the priorities. That's very important. As you can see, in this case, we're sorting based on the item, right? So letter A being the smallest letter in the alphabet, so that's all the way to the top. But we could have the priorities being like 0.0001, so that is most likely to be on the top. So yeah, that's something I want to point out. And then it's gonna throw some illegal argument exceptions. If this is null, you have to write something like this as well in this method. Yeah, so that's pretty much it for this method. And one more thing I want to like kind of remind you guys is that if I insert something here on the 12th or the last element here, what it does is actually, so think about this, right? In this main heap, I'm inserting something here. So I first add it here. We have to compare its priorities with this parents. So whatever I write here, I have to compare this priority with this F's priorities as well. And then I have to keep going. Right. So if this one is smaller than F's priority, we won't actually swap them. So that's when I talk about it will be better for you to have this swap method. So you can just have that right away because there's going to be a lot of swiping that you need to do. Hence percolating up, percolate down. So that's the add method. Now let's talk about the contains method. So this one is pretty easy one. It's pretty intuitive. as it returns true if the PQ or the array heap that we implementing contains the given item, false if it's not. So I would actually implement this, the next one, and also the peak min here. So what peak min does is just going to be returning an item with the least value priority. So the one of the hint that I can give you guys is just here. The this one it just literally gonna be the top one, right? Because we're implementing a min heap. We are doing that. So peak is not removing anything, so we can just return it. And since we're using zero based index array, so we could just return whatever on the zeroth place here. So that's for the min heap. I would say peak, min, and contains is like the easier side of these methods. And actually, let's talk about the remove min after we talk about peak min. So remove min, right? Again, we want to remove the top one because that's the smallest one. That's how implementation goes. But after we remove it, we have to have something replace that A here in this case. So let's say we want to remove A. What it does, we have to place this one to all the way to the top, and then we have to percolate down the L here. So compare, with that being said, we have to compare L's priority with the B's priority and C's priority, which one's like, bigger or smaller goes to the top. You have to decide. So I will leave it that to you guys. So I kind of, another hint I can give you, like I said, it's gonna be percolate down a little bit if needed, right? Percolate down or up is all based on the condition that we compare the two items priorities. Remember that? And then let's talk about, I would say this one is the most challenging one, but the most rewarding one, if you can think of that. I wouldn't give away too much details for this method, but here we're changing the priority. What I can say here, for example, we want to change E's priority. So that means the priority either going to be bigger or smaller. So if it is smaller, you need to do something. And if it's bigger, you need to do something. But you never know. So you have to do both. That's as much as I can give you. And then the last one, of course, the size method. This one, I also have a hint for you. So is that you could just have a field that, name size that keep track of the size as you go for like add or remove.
That's it from us. Thank you guys for watching and good luck on the project.